So in this video, I'm going to show you how to use more advanced formulas to figure out missing parts of a triangle. We cannot use SOHCAHTOA in this example because this is an obtuse triangle. SOHCAHTOA only gets used when there's a 90-degree angle in the triangle. We've got 95 right here. What I'm going to use here to find a missing angle, we'll make it angle B. We're going to use a rule called the law of sines. Now the formula for the law of sines is easy to remember. It's side A over the sine of the angle A, side B over the sine of angle B, and side C over the sine of angle C. You know, the formula is written that way. Little a's are across from big A's. So little a is a side, the side that's across from angle A. Angle B, capital B, is on that part of the triangle. On the opposite side of that triangle is little b. And if over here I've got angle C, capital C, the side that's across from it is little c. So that's how we do our labeling for the law of sines, which might make things more complicated, and even the way that the formula is written with 3 parts makes it seem more complicated. The thing is, we only need 2 of the parts of the 3. So in this particular question, I've got little b, I'm looking for big B, I've got little a, and I've got capital A. I'll be using the A's and the B's, it looks like, for this particular problem. I won't even use the last part of this formula. All I have to do is place those pieces in the right spots. Little a here is 27, sine of 95 here. Little b is 16, and the sine of angle B is below. Now, in this question, I've got to get the sine of B all by itself. To do that, I can cross multiply to get 27 times the sine of angle B equals 16 times the sine of 95. I still have to get the B by itself, and the way to do that is to divide both sides by 27. Once I've gone that far, I can finish the question by using inverse sine. The 27's cancel, and in my problem I'm looking for an angle. To find an angle using trigonometry and your calculator, you would use the inverse command or inverse function of your calculator, and then just type in this mess over here into your calculator, which takes a few seconds to do. Type that all in, I get about 36 degrees. Taking a look at the picture, 36 degrees does make sense, as it looks like a small angle there where angle B is. All right, here's another example of using law of sines. All right, I can also use law of sines to find a missing side. And that's a little bit easier than the last example, actually. But it's the same sort of philosophy or the same sort of idea. When you have a side and an angle that are across from each other, and you're looking for a side that's across from, diagonally across from another angle that we know, we can apply the law of sines to this as well. So, I mean, you can write out the law of sines the full way if you'd like. Little a over the sine of angle A, side B over the sine of angle B, side C over the sine of angle C. And you could fill in on your picture all little A, B's, and C's. Instead of actually filling out the little A, B's, and C's, we can just do this idea of the law of sines and handle it by just thinking it's the side divided by the sine of the angle across from it. So give me a side, x. Give me the angle diagonally across from x, would be angle 43. and then go to the other pair that we have. We've got a side, 12. We've got an angle, 99, so I'd write the sine of 99 there. So you can think about the formula, and you can write down little a's and b's and c's if you'd like, but it's better maybe just to think about it as the side on top and then the sine of the angle below. In this question, we could actually get x by itself very quickly by multiplying both sides by the sine of 43. I guess you could do some cross multiplying, but this is actually the fastest way to get the x by itself. X is equal to 12 times the sine of 43 degrees divided by the sine of 99 degrees. So again, it's just typing into the calculator, and when you type it in, you end up getting about 8.3. This is a good one to actually look at the picture to see, does the answer look like it makes sense? 8.3 for that side right there. Alright, this is 99 degrees. That's definitely the biggest angle in that triangle. Across from it has to be the biggest side. You don't call that a hypotenuse because it's not a right triangle, but this is the biggest angle here, so across from it's going to be the biggest side. So I know that this has to be smaller than 12, so about 8 seems pretty reasonable. I don't think the picture's drawn perfectly to scale, but it definitely looks a little bit smaller from there to there than from here, from A to C. So it's a good one. All right, let's take a look at using another formula called the law of cosines. All right, in this picture here, we are looking for a missing side. We cannot use the law of sines to find the missing side, because to use the law of sines, you need to have a pair going diagonally this way, and then you need another pair going this way or this way, and we're coming up short. We got a match across the way this way, but the 375 does not have a match in that for that angle. This angle is left blank, so the law of sines would not be something that you could use. Instead, you're going to have to use a pretty complicated looking formula called the law of cosines. The law of cosines, the formula can be written like this, which looks like the Pythagorean theorem. It is a Pythagorean theorem, but the Pythagorean theorem only works for right triangles. When you're dealing with triangles that are not right triangles, you have to add on a little bit more to it, or actually subtract a little bit more to it. So it starts off looking like the Pythagorean theorem, and then it's the number 2 AB times the cosine of angle C. All right, so finding the right numbers to place in here is what we need to do. Well, if you look at the picture, there's only one angle in the entire picture, 35 degrees. And in the formula, there's only one angle, so that has to be a 35 degrees right there. So it's going to end in 35, the cosine of 35 degrees. If this is our angle C, then the side on the opposite side of the picture is little c. So this is going to start with the side we're looking for, and then the rest just snaps into place. The A's and B's are just the other sides. This could be A and this could be B, and you just have to place the numbers into the formula and take a little time to figure it all out. And I just have enough room to squeeze that all in. Alright, so all we need to do is type in all of this to the right into the calculator, and then we're going to have to finish by square rooting, just like we would finish with the Pythagorean theorem. Alright, so I'm going to plug this into my calculator. It takes a few seconds. Alright, all that work to get this number here, 5,000 54,879.38671. That's what x squared is worth. If I square root both sides, I'll be able to figure out how long the missing side is. And I get approximately 234 meters. Looking at the picture, it makes sense. This is a pretty small angle. It looks like it's the smallest angle in the triangle. So this should be the smallest side, 234. Makes sense. All right, one more example. I'm trying to give you one example of each type of situation. All right, here is one where we're given all three sides. This is one of my favorite ones because it's showing that you can actually measure an angle without using a protractor. If all you had was a ruler, you could find a measure of an angle that's in the picture. So, for example, in this one here, let's suppose I'm looking for this angle here. Now, let's talk about which formula to use. Law of sines. Law of sines says that if we have an angle that we're looking for, and we get the side across from it, we could figure it out with the law of sines if we had another angle and a side across from it. But we don't. All we have is just this mystery angle that we're looking for. We don't even know what those are. So law of sines, even if you tried to use it, wouldn't work. This again would be the example of using the law of cosines. My little slogan that I like to use for the law of cosines is that it's easy to remember. And that's how I memorized it in college, I guess it was. How is it easy to remember? Well, what's easy? The easy is Pythagorean theorem. C squared equals a squared plus b squared. This is my way of remembering it, remembering the formula. So the easy part is the Pythagorean theorem. And then that little dash in my little way to remember it is the minus sign. The 2 is the number 2. And remember your ABCs. I don't know why this comes to mind when I do this, but maybe because someone's like, oh, you remember your ABCs when you're little? You learned about your ABCs, so remember your ABCs. So AB cosine C. All right, you didn't have to know that little slogan, but that's the way that I usually remember the formula or first learned it. So, all right, so it's all about plugging things in. There's only one angle in the picture, that's x. So I know how this formula is going to end. It's going to end with the cosine of x. If x is the angle, and in the formula the angle is capital C, then that must mean that little c is the number that's across from it in the picture, because they go together, the capitals and the lowercase. So this means that 4 would be my c squared, and then the rest just snaps into place. So a would have to be maybe the 2, which forces b to be the 5 minus 2 times 5. And I'm almost there. I just have to do a little more work with this. 4 squared is 16. 2 squared is 4. 5 squared is 25. 2 times 2 is 4 times 5 is 20. And I could use the calculator for some of the smaller math if I really needed to, but I like to sort of just work it out as much as I can by hand. I get 16 equals 4 and 25 make 29, minus 20 times the cosine of x. And this is the one that takes the most discipline maybe to finish. I got to figure out how to get x by itself. To do that, I'm going to subtract 29 from both sides. Of course, gives me negative 13. Equals negative 20 times the cosine of x. I want the x to be by itself. I've got to get rid of multiplying by negative 20. I do that by dividing by negative 20. And I get a positive 0.65. on the left-hand side. On the right-hand side, I've got the cosine of angle x, and that puts me at the very, very end. If I'm looking for the angle, and I've got sine, cosine, or tangent, I'm going to use the inverse function to get there. And all I have to do is type in the inverse cosine of 0.65. And whammo, about 49 degrees for the answer for x. And I can take a look at the picture and then judge whether or not the answer makes sense by looking at the picture. Picture seems a little bit, I guess 49 seems about right. Yeah, it's an angle, it's a little bit bigger than 45. Yeah, it's probably a pretty accurate picture, and the answer does make sense. All right, that's how you do tackle these more advanced ones. It's going to be more important to understand how to do these advanced ones in January, and a little less important in June. So good luck. I know it's not so easy to do, and we'll be practicing in class, of course, to get you sharper and sharper on these things. All right, so continue to work really hard, and hopefully the video made a lot of sense to you.